In this video, we'll start to extend off of adding integers to adding different types of rational numbers, focusing on decimals and fractions. So we've been working a lot with adding integers, and they follow the rules depending on what signs of those numbers you have. If they're different signs as each other, such as you're trying to add a positive to a negative, those are trying to cancel out since they're opposite signs. So we've learned to subtract those base numbers, bigger minus smaller, and keep the sign whatever you have the most of. If they're the same signs, like two negative numbers that you're adding together, there's nothing there to cancel. So instead, those are trying to combine. You would add those base numbers and keep the original sign. So if we're looking at some examples, the very first thing to check would be the signs of those numbers. So looking at number 1, a -4 plus -10, I see that those are the same signs as each other. So I'm really thinking of adding those base numbers and then keeping a negative for my final answer. In number 2, a +3 plus -8, those are different signs, so I'm really thinking of subtracting those base numbers and then seeing I have more negatives to make my final answer a -5. If you're following along, number 3, -12 plus 6, I would expect that answer to be a -6, subtracting them since they're different, negative since that's what I have more of. For number 4, -15 plus -6, that would give me an answer of -21. Those are the same signs, so they're combining to get more negative from there. So hopefully this diagram looks familiar. It walks you through what's called the rational number system. And in the middle of this jawbreaker looking diagram is the most specific category, and then as you go out, it gets to include more types of numbers. So you may have heard of the natural numbers as counting numbers. And if you think about counting, let's say to 10, you start with numbers like 1, 2, 3, and so on. So natural numbers are those positive whole numbers, no decimals, no fractions. And why I love this nickname is because it reiterates that when you count, you don't actually include 0. You start immediately at 1. Now with whole numbers, that's where it includes that 0, and I like to remember that because of the word whole has that visual reminder. So whole numbers are positives, still no decimals or fractions. The difference is we would finally include 0 in that mix. Integers are where we've been working the most. Those are positive and negative numbers without decimals or fractions. So things like -2, -1, 0 is still included, as well as those positives. And then finally, rational numbers involve a lot of different types of numbers. We see decimals that end, or decimals that repeat, even if they're negative. We include fractions or negative fractions, as well as everything in between, like a negative whole number, or 0, or 1. So the best way to describe all of those different types of numbers are numbers that can be written as a fraction. So we could turn 0.5 into its equivalent of 1/2. Even a number like 1, we could turn into a fraction by putting it over 1, and things like that. So we've been focusing on integers, but you can see since an integer is a type of rational number, that means that all of these rationals like negative decimals or negative fractions will follow the same rules. So again, if you're trying to add positive or negative decimals, since those are rational numbers and integers are rational as well, we can still use that same or different signs to help us figure out how to solve them. Remember, when adding and subtracting decimals, the only extra rule is to make sure that decimal point and the digits places are all lined up. So if we work through these examples, I see a -5.46 plus -12.32, or 32 hundredths. Those are both negative, so they have the same sign, so I'm going to add those bases together. A 12 and 32 hundredths plus a 5 and 46 hundredths. Notice, again, I am lining up that decimal place. So then as I work my way down to add these together, I would get a 17 and 78 hundredths. Looking back at my original, since I'm adding two negatives, my final answer would also be negative. For this next example, I have a +7 and 2/10 plus -11 and 607 thousandths. This time I see one of each. I have a positive that I'm adding to a negative, so I would set it up as subtraction. Bigger base number on top minus that smaller one. Remember here, if this happens to you, you just fill in those gaps with a 0. So working through this time, subtracting those numbers. And I'd want to check which one I have more of, which in this case would be negatives. So hopefully this feels very familiar to you because we've spent a lot of time on adding integers and they follow those same rules. Just takes a little bit longer and making sure that the decimal place is lined up. Same thing would work for fractions. With fractions, the only extra rule is to make sure you get common denominators, and I recommend doing that first. So remember, you cannot add or subtract fractions together until you make them equal sizes of those common denominators. So looking at my denominators of 4 and 3 on this first example, a number that 4 and 3 both go into would be 12. So to get fourths to 12ths, I would need to multiply by 3. To get thirds to 12ths, I would need to multiply by 4. So 3/4 would be the same as 9/12, and -1/3 would be the same as -4/12. Notice when I got my common denominators, I kept the original sign even after I changed them. So now when you're going to add these fractions, I'm really focusing on my numerators. I have a +9 and a -4. Those are different signs, so I would subtract them, really thinking of 9 minus 4 to give me 5/12. Remember, you keep that denominator the same. Now looking in the common denominator section, not the original problem, I have more positives, so my answer would stay as a positive 5/12. So after you get common denominators, you're really focusing on those numerators and handling them as if we were having just integers. Now for our second example, I have a -1/6 plus a -5/8. You might be tempted to multiply the first one by 8 and the second one by 6, but there's a smaller number that works as well for a common denominator, and that's what I'm going to use. 6 and 8 both go into 24. So to get 6 to 24, I would need to multiply by 4. To get 8 to 24, I would need to multiply by 3. So my common denominators would change to -4/24 and then plus a -15/24. Again, just like that first example, if it started as a negative, I made sure to keep that and not forget my sign. So now that I have a common denominator, I'm focused on my numerators. They are both negative, so I would add those base numbers together. So 4 plus 15 would give me a 19. So I would have 19/24, but since they were both negative, I need to make sure that my final answer is negative. Now let's say you did not remember that 6 and 8 both went into 24 and you got 48. That is totally fine. You would just need to make sure that to check your final answers if you can simplify. Now calculators are wonderful things and you can use one to make sure that you're getting the right answer. If you have this type of calculator, a couple key buttons to remember. The negative sign has its own button down here at the bottom. If I was trying to type -9 plus -3, I would not want to use that minus button. So I would hit that -9 plus -3. Same thing with these next examples. Now, if I was trying to do a problem like number 4 on my calculator to check, this ABC button here is your best friend with fractions. So I'll actually write out what buttons you would press here. For a -7/9, I would hit that negative button first, 7, ABC, 9. Think of the ABC as like the line in your fraction. And then if I wanted to add a -2/3, again, I would hit that -2, ABC, 3. And then after you hit equals, that should give you your final fraction. So feel free to use these to check your answers. I would encourage you to try as much as you can or set them up without one, but then use that tool to check and see how you did.